Okay, I'm going to show you guys how to factor x to the fourth power plus 1. And as you guys know, if this was a 2, then this is not factorable. But since we do have a 4 right here, this is in fact factorable. And let me show you guys how. First, we'll look at this as a sum of two squares. So I'll put this down like this. And then to fill in these parentheses, we know we have to put down x squared. And then for this one, we just have to have a 1. So they are the same, right? And now, we have pretty much a squared plus b squared. And notice, for all the perfect square, they all involve a squared plus b squared, right? And this is the one I want to use. I will write down something squared plus 2 times something times the other one plus something squared, and I will fill in the parentheses. For the first one, I'll put down x squared, and then for this one, I'll still put down x squared, and then for this, I'll put down 1, and for this, I'll put down 1. However, this is no longer the same as the original, but we can make it the same, because this is just the extra term from the original, right? So therefore, I can just go ahead and subtract this, which is 2 times x squared times 1, and now they are the same thing, right? And then you see that the first three terms like this, we have x squared plus 1 squared, right? And then for this, we know this is just going to be a minus, and then we have 2x squared pretty much, right? And let me put that into something square as well. So let me open the parentheses with a square, and here we have 2, so that means inside here, I will have to have a square root of 2. Square root of 2 squared is a 2, right? And then this is x squared, so I have to have the x right here. And now, this is the difference of two squares. I can just go ahead and factor it the usual way. So therefore, we have x squared plus 1, and then minus this, which is square root of 2x. And then the second one is going to be x squared plus 1, and then plus this, which is square root of 2x, right? And usually, we want to write it down in a nice order, so let me just rearrange this a little bit. Therefore, the final answer is x squared minus square root of 2x plus 1, and then times this, which is x squared plus square root of 2x, and then plus 1, all right? So this right here is how we factor x to the fourth power plus 1. And now, move on to the next part. Okay, now let's do a partial fraction for 1 over x to the fourth power plus 1. And we know from the previous part that this is factorable into two quadratics. So we know this is going to be something over the first factor. Let's write down x squared minus square root of 2x plus 1 plus the other thing over x squared plus square root of 2x plus 1, right? And because they are both quadratic, that means we have to have a linear on top, right? So right here, let's write down ax plus b. And then for this one, let's set out cx plus d. And let's do a partial fraction the usual way. Let's go ahead and multiply everything by the lowest common denominator, which is this times that. So let's go ahead and multiply x squared minus square root of 2x plus 1 times the other one, x squared plus square root of 2x plus 1. And notice this times that is nothing but just x to the fourth power plus 1. When you take this times this guy, it's just going to be have 1 left, right? So that you have 1 right here. And then when you have this times that, these factors cancel. So we have ax plus b right here left. And then we multiply with the second factor, which is x squared plus square root of 2x plus 1. And then we add it with, you know, this and that will cancel. So that means we have this times that. So namely, we have cx plus d times this, which is x squared minus square root of 2x plus 1, right? And now, this is the fun part. You go ahead and distribute everything right here and then just set up all the things, right? Anyway, ax times this is ax to the third power. X times this is going to be plus square root of 2a. X times x, of course, is x squared. Ax times 1 is just plus ax like this. And then b times this is plus bx squared. B times this is plus square root of 2bx plus b times 1, which of course is just b, right? And now we'll do this times that, and I'll put it down below here. So you just go ahead and do that. So we have cx times that, which is going to be plus cx to a third power. This times that is going to be minus square root of 2cx squared. And then cx times 1 is just plus cx. And then this times that is plus dx squared. This times that is minus square root of 2dx. And then this times that is just plus d. Aha, this is what we have. And now let's just set up the coefficients. For example, you know this right here, it's a coefficient of x to a third power on the right hand side. But unfortunately, on the left hand side, we don't have x to a third power at all. That means a plus c has to be 0. So that's the first condition right here. A plus c has to be 0. And now let's combine all the x squared term. Namely, we have this right here. Let's just put down underline like this, and then this is another 2 right here, right? So we have this plus that plus that. Sorry, this minus this and then plus that, right? So in other words, we have square root of 2a minus square root of 2c and then plus b plus d. All this right here is the coefficient of x squared on the right hand side. But once again, we don't have x squared on the left hand side. That means all this has to be 0. That's good. And now move on to the x terms. So right here we have ax, and then right here we have cx, right? And also this right here is a plus square root 2b and then minus square root 2d. And now we will just put them together. So let's write it down right here. a plus c and then plus square root of 2b minus square root of 2d. All of this is equal to what? It's equal to 0 because on the left-hand side, we don't have any coefficients for the x. It's just 0, right? At the end, we have this, which is b plus d. That's a constant term. So let's write it down. We have the b plus d. It's a constant term. This is equal to what? On the left-hand side, we do have a constant 1. So that means this has to be 1, right? And now what? We have 4 equations with 4 unknowns. Let's go ahead and good luck, right? Anyway, it's actually pretty easy because as you can see, a plus d is equal to 0. That means this is going to be 0, isn't it? And that means we have this and that, right? It's just 2 equations with 2 unknowns right here only. And I know in the previous video, people told me to do this and that and whatever, but I want to do it my way. I don't care about your way. It's my video right here, right? So let me go ahead and multiply everything by square root of 2 right here. And as you can see, this right here is going to be square root of 2b minus square root of 2d equal to 0. And right here it's going to be square root of 2b plus square root of 2d is equal to square root of 2 times 1, which is square root of 2. And then as you can see, we combine this and that will cancel, and then this is going to be 2 square root of 2b. It's equal to what? Square root of 2. And then of course, let's go ahead and divide both sides by 2 square root of 2. So we get what? This and that cancel, this and that cancel, this and that cancel. Namely, b is equal to 1/2. And if you look back to here, b plus d is equal to 1, and you know b is equal to 1/2 already. That means d has to be 1/2 because half plus half is 1, right? And you see, if you talk fast enough or work fast enough, this is not that bad at all. And now let's look at this. How can we solve for a and c? Well, we know b plus d is equal to 1, so we know this right here is equal to 1, right? And now I would like to multiply this equation by square root of 2. And then you will see that on the top we have square root of 2a plus square root of 2c is equal to 0. And this is going to be square root of 2a minus square root of 2c. And let's move the 1 to the right hand side. So we have this is equal to -1. And then from here, you see that this and that will cancel. And now we have what? This and that is going to be 2 square root of 2a is equal to -1. And of course, now we divide both sides by 2 square root of 2 square root of 2 like this, so they cancel, and now we have a is equal to -1 over 2 square root of 2, and this is going to be right here for the a, and then we have the b and d right here and right there already. At the end, we have to find c. Well, if you look at this right here, a plus c is equal to 0, that means a has to be equal to -c. Then because a is -1 over 2 square root of 2 already, that means c has to be the positive version. So in other words, c has to be 1 over 2 square root of 2, and this is the positive version. And at the end, of course, I will just leave this to you guys to plug in a, b, c, d into a, b, c, d right here. Now, moving on to the third part. Okay, for the third part, we're going to complete a square for this and that. So you can see for the first one, we are going to write this down as x squared minus square root of 2x, and we leave a space for the magic number. I will show you, don't worry, all right? And then we put down a plus 1. So what's the magic number? First of all, be sure that we have a 1 in front of x squared, which we do right here, right? And now let's look at the coefficient of x, which is negative square root of 2. And then for the magic number, you have to know this formula. We take 1/2 of the coefficient of x, which is going to be negative square root of 2, put it in parentheses and square that. And then you see 1/2 of square root of 2, right? This is going to be 1 over square root of 2. And then this is negative, so be sure you have the negative 1 over square root of 2 like this, and then square that, and you get 1/2 positive at the end, right? At the end, right here, we add 1/2, and don't forget to subtract 1/2 right afterward. And for the first 3 terms, this is going to be a perfect square. And if you show all the work right here, you know it's going to be x, and this number right here. So these 3 terms is going to be x minus 1 over square root of 2 square, and then of course 1 minus 1/2, you know this is just plus 1/2, all right? So this right here is the complete square version of that. And as you can see, this is just plus. So all you have to do is pretty much the same thing. You still will add 1/2, subtract 1/2, and then for the factor, you will have the plus instead of the minus. So this is going to be x plus 1 over square root of 2 square, and then plus 1/2, all right? So this is it. Now, final stage. Okay, finally, we can be integrating 1 over x to the fourth power plus 1, and we know we're going to use the results from the previous part, right? So let's go ahead and do that. First of all, you know we're going to break this down into 2 fractions, and that means we can break this integral into 2 integrals, right? So first of all, let's write this down as integral, and then for this fraction, let's put down the one with x squared minus square root of 2x plus 1, but we completed square for that already, so that means we can write this down as x minus 1 over square root of 2 and then square plus 1/2, right? And then the corresponding numerator is going to be negative 1 over 2 square root of 2x plus 1/2, and we could close this integral right here. And then for the second integral, you know it's going to be similar, but instead of the minus here, we have the positive version, right? So that means we can say let's add another integral, which is we have 1 over 2 square root of 2, and this is positive version, and then we have the x, and this is still positive 1/2. And then for this denominator here, we have the positive version, namely x plus 1 over square root of 2 squared plus 1/2, right? And you see, they are really similar. Let's just go ahead and do this one first. And then for the second one, I'll just tell you guys what the answer is. To integrate this, we have to use a u sub. Let me go ahead and say u equal to this, which is x minus 1 over square root of 2. And you see right away, du will be the same as dx, which is great, right? And now, notice on the top, we have this x. So that means we should isolate x right here. So in other words, see x is equal to, let's add this on both sides. So we will have u plus 1 over square root of 2, right? That's great. And here we go. We are going to do the top. So here we have the top. It's going to be, let's write it down as negative 1 over 2 square root of 2. And for this x, which is this, let's write it down as u plus 1 over square root of 2. Close that, and then don't forget to put down the plus 1/2 right here. Do this really, really carefully, all right? And as you know, we are going to distribute, no problem on that. So this times that is just going to be negative 1 over 2 square root of 2u. This times that, we know it's going to be negative. 1 times 1 is 1. Square root of 2 times square root of 2 is 2, times this 2 is 4, so we have negative 1 over 4. Plus this 1/2. What's negative 1 over 4 plus 1/2? It's positive 1/4, right? So we add it with 1 over 4. And yes, that was the part that I made the mistake in the previous video. This and that together, we have the plus 1/2. Okay? And that was the reason why I'm making this video. But it's all good. I don't mind because I'm having tons of fun anyway. Anyway, right here, the top is equal to this. In other words, now we can take this integral from the x world into the u world. So we will see, we will have the integral on the top is just this now. Let's write it down, which is negative 1 over 2 square root of 2u, and then plus 1 over 4. And then for the denominator, as you can see, this is the u, so we have u squared, and then plus 1/2, and then dx is the same as du, so we can just put down du on the side. And how can we integrate this? Well, once again, we want to split the fraction. Then to split the fraction, you see this is a constant multiple, so let's bring that to the front first. So namely, we have negative 1 over 2 square root of 2, and then first integral, we have the u on the top over u squared plus 1/2 here, and let's close that. And then for the second integral, once again, we have a constant multiple right here, which is 1 over 4. So that's plus 1 over 4 right here, and then the integral right here. And then this time, we have a 1 on the top only, and then over u squared, right? And this time, you know, on the top, we don't have a 1. So this is going to be the arctangent formula, right? So that means I should look at the 1/2 as plus parentheses something squared du like this. So what should I put down in the parentheses? Well, this is 1/2, put in here and something squared, so I will have to look at that as 1 over square root of 2 squared, and that's the same as 1/2, isn't it? And now, let's go ahead and integrate this and integrate that. So for this one, we still have the negative 1 over 2 square root of 2, right? And then to integrate this, you have to do another substitution. Maybe say w, let w equal to the denominator, and dw is going to be 2w, right? dw is going to be 2u. And then you see that we only have a u on the top, so that means we have to have a 1/2 factor right here. And then you know it's going to be ln, and then the denominator is u squared plus 1/2. But you see, u squared is always positive plus 1/2. So you know this is always positive, so we can just put it on parentheses. And we're done for that. And now let's put down plus. This is 1 over 4. And you know, once again, this is going to be the arctangent formula, right? And the formula says, when we have to integrate 1 over u squared plus a squared, the formula is 1 over a, namely the reciprocal of this number. This is 1 over square root of 2 already, so that means I will have to do the reciprocal, which is square root of 2 over 1, like this. Then just write me down like this, right? And then we have the inverse tangent, and the variable that we're using is u, and then once again, inside it's actually u over a. A is this, so we have pretty much square root of 2 over 1, which is the reciprocal of that. And we are done with the integration part, okay? And now we are just going to take this result from the u world back to the x world. So as you can see, this is just a clean up. Negative times that, which is negative 1 over 2 times 2, which is 4, and we still have the square root of 2 right here, right? And then we have the ln parentheses. And now, what is u squared plus 1/2? Well, we know that u is equal to x minus 1 over square root of 2. But better yet, you see, this right here is this, which is u squared. And then after that, we have the plus 1/2. As I mentioned earlier, this denominator came from the one before we complete a square. Namely, we have x squared minus square root of 2x plus 1, isn't it? So in another word, I can just enter this right here, which is really nice. So x squared minus square root of 2x plus 1, like that, and close the parentheses. That's excellent. And now, how in the world can we simplify this guy right here? 1 over 4 times square root of 2. And let me write it down as square root of 2 times square root of 2 times square root of 2 times square root of 2, yeah? So that you see, this square root of 2 and that square root of 2 cancel, and you see, square root of 2 times square root of 2 is a 2, and then we have one more square root of 2. Namely, we can say this is plus 1 over 2, that's a regular 2 right here, and then this is another square root of 2, okay? And then this is the inverse tangent, and inside here, what do we have? We have square root of 2 times u, and once again, u is what? U is this guy, isn't it? So we are saying what we have here is square root of 2 times the u, which is x minus 1 over square root of 2. Of course, distribute, right? So altogether, we have square root of 2x right here. Let me just put it down in blue. Why not? All right? Square root of 2x, and square root of 2 times this is just basically minus 1. And we are almost done, because this right here is just for the first integral. So all in all, for the second one, you know it's going to be almost the same, right? But let me just make it complete for you guys. So here is the final result. Ladies and gentlemen, to integrate 1 over x to the 4th power plus 1 dx, let me write down this right here in black, which is all this right here. So the result is going to be, we have this right here, negative 1 over 4 square root of 2 times the ln parentheses x squared minus square root of 2x plus 1, and then plus 1 over 2 square root of 2, and we have the inverse tangent, and we have square root of 2x minus 1, like that, okay? And for the second integral, let me just put it down in red. Of course, black pen, red pen, I have to have the red right here, right? For this one, I'm just going to show you guys what the answer is. Instead of the negative, in fact, you actually have the positive. So we will have plus 1 over 4 square root of 2, and then ln still ln, and we have x squared, but instead of the negative right here, we have a positive, and then square root of 2x plus 1, like this. And lastly, we have plus, actually the same constant, 1 over 2 square root of 2, and then we still have the inverse tangent right here, and then instead of this negative, we have positive, all right? So we have square root of 2x plus 1. Oh my God! At the end, put down a plus in blue. Ladies and gentlemen, here is the answer. All right? So I redeemed it myself today.
So good.